All right, so I'm recording, everybody. The question says, find the normal, right? Find the normal. Is that it? Let me see again. Find the equation of the normal to the curve. Yes, x equals y equals x plus 6 over x at the point where x equals 4. All right, beautiful.
Yes.
So the first thing I would try to do is, since we know that this function has a normal at the point where x equals 4, the question will be, okay, but what is the full coordinate? Because in previous exercises, we had something like this. At the point P, 3, 4, or something like it. We had the full coordinates, and we needed those to be able to find the full equation, the full linear equation. But in this case, we were just given the x. It's as if we were given something like this. 4, something. And we don't know that something right now. So the first step I would do is find the coordinate y for this point. Wait, what's going on with the camera? There. It's focusing now. All right. Find the y coordinate of the camera, of the point.
Mhm.
Okay, so what I would do is do exactly that. And to find that, look at the main equation. Our main equation is telling us that we can find the value of y by a given point x. So if we replace the value of 4 in the function, we are going to be given the value of y, our point, our coordinate. So by replacing x equals 4, by replacing, I'm going to have y equals x, which is 4 plus 6 over 4. And now we have an addition of fractions. Now, you can do this using any type of process you choose. You can do it with the calculator, whatever. I'm going to do it real quick with mathematics, right? With algebra. So I'm going to amplify the first equation by 4. By amplifying this one by 4, I'm going to have the same denominator, which is 16 over 4, and then 6 over 4. The same denominator, right? I just amplified. What's going on with the camera? There. I just amplify my function. Now, I can see that the solution will be over 4, because I leave the same denominator, right? And then I add the numerators. So 16 plus 6 will be 22. 22 over 4 can be simplified. This will be 11. Let me write it here. Y equals 11 over 2. So now we have our point. This will be the point 11 over 2. X 4 for x and 11 over 2 for y. Now that we have the variables, now that we have our coordinates, now we can continue the process just like in previous exercises. If we want to find the normal, what we need to do first is find the slope at that point and then find the inverse, right? Finding the normal. So let me do it right here. There, something like this. Okay, let me read it right now. To find the slope, what we need to do is find the derivative of the function dy over dx. But look at this. Finding this derivative with that x in the denominator will not be easy. I'm going to change that. I'm going to change it so that the denominator doesn't have an x down. I'm going to put it as a y equals x plus 6 times x to the negative first. By doing that, remember the x is no longer in the denominator. I put it up, and now I can find the derivative of that function. To find the derivative, let me change the notation this time, because why not? Y prime will be 1 plus, remember the derivative of x is 1 because the coefficient is 1, and then the derivative of 6x to the negative first. How would you do that? Exactly the same as you would find the derivative of any polynomial function. Just multiply the coefficient by the exponent. So 6 times 1 will be negative 6. And then the exponent will be, the new exponent will be the same one, but minus 1. So negative 1 minus 1 will be negative 2. Beautiful. Now we have our derivative. All right. To write it prettier, to write it better, I'm going to do 1 minus 6 over x to the 2. Remember, mathematicians, we don't like negative exponents. We like it positive. So that's why I'm putting it in the denominator. From here, I want to find the slope of this function at exactly the point x equals 4. So all I have to do is change the x by 4, and then I will have the slope. So this slope will be, look at this, I am changing already for m, because I know the moment I change x for 4, I am going to get the slope at that point. So m will be 1 minus 6 over 4 to the second power. Remember, I am changing x by 4 because I want to find the slope of this line at exactly x equals 4, at exactly that point. Do this in the calculator or with algebra, and I'm going to have the slope of, all right, let's see, 1 over 1, and this will be 6 over 16, right? So I can amplify this function. This will be 16 over 16, right? And if I do this subtraction, I'm going to have that the slope is 16 minus 6 will be 10. Wait, looks like a 16, sorry. 10 over 16, remember, same denominators, so I leave the same denominator, 16, 16, I leave 16, and then do the operation with denominators. So 16 minus 6, that is 10. Beautiful. This thing can be simplified. It can be simplified by 2, so 5 over 8. That'll be our new slope, but the slope is the slope of the tangent. I'm going to write mt, because this is the slope of the tangent. But I'm looking for the slope of the normal, because that is exactly the question. Find the normal, the equation of the normal at this function at this point, right? The normal of this function at exactly x equals 4. So now I have the slope of the tangent. How am I going to get the slope of the normal? All right, in case you didn't know, the slope of the normal, mn, slope of the normal, is the same as negative 1 over the slope, the slope of the tangent. All right? This is called the reciprocal opposite. What I'm saying is, whatever is down, put it up. Whatever is up, put it down, and put a negative to it. That is it. Let me show it to you. The slope of the normal, will be negative 1 over, this is negative 1, over the slope of the tangent. And the slope of the tangent will be 5 over 8. You can barely see the marker, 5 over 8. There we go, better. All right, so the slope of the normal, is now, if you do the algebra here, if you do the algebra right, you're going to put a 1 there, and you can do the rule of multiplying, of dividing fractions, right? The solution will be 8 over 5 and then a negative. So take a look at this. How did you find slopes of normal functions? If you have the slope of a tangent, just the 5, whatever is up, put it down, so the 5 is going to go down. And whatever is down, put it up. So it's going to go up. The 8 is going to go up. And then put a negative to it. That is why this is called the opposite, because of the minus, and reciprocal, because whatever is up, put it down, and whatever is down, put it up. Now we have the normal, the slope of the normal. But we know, since this is a normal line, it is in the form y equals mx plus b. This m, since it is a normal, has to be the slope of the normal, mn, right? Because we're finding the normal. And from here, the process is exactly the same. We have our slope, negative 8 over 5, and we have our point, 4, 11 over 2. So now we can find this line. I'm going to do it real quick. From here, replace the values that we know. and isolate. All right. So I know the y coordinate is 11 over 2. So this will be 11 over 2 equals the slope of the normal, mn, the slope of the normal. This is negative 8 over 5. So negative 8 over 5. Let me write this negative a little better. There we go. Times x, but the variable x will take the value of 4 in exactly this point. At exactly x equals 4, we'll have the value of 4. And then this is plus b. We don't know the value of b, but we can find it. Isolate for b. All right, let's see. 11 over 2 will be equal to, by multiplying these fractions, all I have to do is put a 1 down and multiply up with up and down with down. That means numerator with numerator and denominator with denominator. Negative 8 by 4, 32, negative 32, right? And then 5 by 1 will be 5. This is plus b. To isolate, pass the negative 32 over 5 to the other side to subtract. But in this case will be to add because of this negative, right? I don't have enough space. Let me do it right here. I don't have enough space, sorry. Okay, so 11 over 2, and then pass the 32 over 5, so plus 32 over 5 will equal my value of b. Do this in the calculator, but I don't have access to a calculator, so I'm going to amplify my my fractions. I'm going to multiply this one by 5. You can barely see it. Sorry, I'm going to change colors now. You can amplify this one by 5 and this one by 2. By 2 and by 5. By doing that, by doing exactly that, the denominators are going to be the same. Down, the denominator will be 10. 2 by 5 is 10, 5 by 2 is 10. So the denominator will be 10, right? Now, what goes in here? 11 plus 5. I'm sorry, 11 times 5. This will be 55. And then 32 times 2. You can see that 55, sorry. 55. There we go, a lot better. And then 32 times 2 will be 64, right? Again, what I'm doing is multiplying these fractions, and to do so, I am amplifying the denominators, amplifying each fraction, so that the denominator is the same. I choose to amplify so that the denominator were 10. I could multiply by something else so that the denominator will be different, but I feel like 10 is easier. All right, from here, add the values in the denominator, and this is 55 plus 64, so 9 over here, and then 119 over 10. This will be v. I have the value of b, this one over here. So all I have to do now is rewrite the answer. I'm going to do it in green. My final solution, the final normal line at the point x equals 4 will be y equals m of the normal, so negative 8 over 5, all right, plus the value of b. But the value of b is 119 over 10. And that would be the solution. Look at that. Woo, this one was good. This exercise was good. All right. All right, my students. Hopefully you got the idea with this one. Again, if you have any questions, let me know, all right? Did you get it?
So we have to make those exercises in 1 minute on the exams?
No, this one will probably have like 3-4 marks. Probably this one will have like 3-4 marks.
Okay, teacher. Thank you.
Thinking something like this. The exercise might give you question A, for example, find the value of the y coordinate. So that will be 1 mark.
Okay.
That's 1 minute, right?
Okay.
And then find the slope of the normal. That's another minute. That's 2 marks right there. And then find the solution. That's around 3 minutes, around 3 marks. Yes.
Okay,
No, could you imagine do this in 1? I couldn't even do it in 1. Not.
Okay.
You're going to take a lot more time. No, don't worry. Remember, guys, if you have any more questions, let me know. I'm going to leave this in the board in case any of you find it interesting. And I will be uploading this question to YouTube, all right? Thank you.
Um,